I like that we don't have bells, but occasionally I get mildly frustrated that there is no, like, okay, get there. Like,
oh, are you going to check our notes?
No, actually, the sub left a great note. You guys were awesome.
But you said you're going to check our notes.
No, I left the note that
everyone's
if you guys
thinking
missed
that's
these
changed.
slides, I would check notes. Alright, so we've been given a challenge. Now, I don't like the header on this paper, because it makes you think that the triangles are similar, which is not necessarily true. We are investigating. So we do not need your computer right now.
Okay.
So, well, you need a computer. Well, you will need one, so go ahead and get it. What? It goes away when you go to a different page. So you open a new tab, and you'll see your bookmarks and everything.
No, I mean like where it's like smaller.
Oh, and see, you have to go to a book. You have to go to a lesson, and you can hide bookmarks. Good, I don't know what I'm talking about. I think it is the full screen button, Jacob. Jacob, are you trying to do this?
No, I'm not trying to.
Okay, then can we move on to fix that issue later then? Because we do not need the computers right now. Alright, so question for you guys. Well, and this is not really something to be answered right now, but if we are to prove two objects similar, how can we do that? So you, with the tools available to you in this room, must as a team come to a conclusion of whether or not these triangles are, in fact, similar to each other. If they are, you have to tell me what sequence of transformations, translations, whatever, can get us from one onto the other, and if, because I know what you're going to claim, if there is a dilation, you need to be able to tell me where the center of dilation is.
I just hope you
like,
not
be able to show me.
I just hope that
So, I'm going to give you like 7 minutes, probably. So, everything in the classroom is at your disposal.
Everything?
You know your objective. Yeah, whatever. I mean, open my closet, go through my stuff. I got a candy drawer if you want.
The arsenal?
Did you say is candy part of the arsenal?
No, your
answer. That is your answer.
There is no answer. There's like the teacher version of the textbook, but there's really no just like answer key.
Chris, I already got stuff.
Yeah.
What is this candy?
Usually,
Christopher,
maybe then we could discuss the candy.
Christopher, I got your stuff.
So
this thing looks like it's 70.
Hey guys, I'm just going to sit and listen to you guys. Okay? You're significantly better at this than I am.
And they know, like, Mr. Sherg and I both learned math back in the dark ages of like the old math. And yeah, so how you guys learn is totally different.
Okay, that bottom angle's on
I find progress.
Notate when you find out. Right, so if you measure something, then label it.
Are you just saying about that?
This one is 30.
This one.
I bet this one. Then that one should be 30. Yeah.
So remember, we used our homemade pantographs for making a dilation, but if we're just finding a center of dilation, how does the center of dilation relate to both shapes?
No, not just for kicks. I know for proving that Alright, fine.
This one's 40. Chris, you got 40, 30.
Are we rounding?
I'm walking away. You need me, let me know.
It's the same angle.
What's better to measure in, inches or centimeters?
Centimeters.
To be more
Let's
precise.
measure the size.
Inches are stupid.
You know, I don't know if we need millions of the inches. They didn't do anything creative.
Wow,
that was American.
Guys, all the angles
There
are
are 2 countries in the world that use the imperial.
Purely like
Yes.
But
7.17.
Okay.
this is exactly.
Yeah, the imperial system is stupid. It's pretty much just someone rolling dice.
Oh, go Club J, by the way, since I know a lot of you guys are in that.
Oh,
I am properly terrible.
It's like my favorite. Yeah.
So,
The only one I like. So yeah.
Wait, let me
This
is like 7 around.
I didn't know how to play exactly.
So wait, Thomas, why are you working on Amber's desk, and where is your paper?
I don't care about the
Well,
It's not important.
well,
If all three angles are the same, that's simple.
Thomas,
I don't know where mine was.
Thomas, here's
No,
another.
wait.
Merry Christmas.
Yes. Yeah. So we
I
don't.
like that we're working together, but you're kind of encroaching onto the space there. So.
What was that? Okay. Do we?
So I see a lot of angle measurements. Based off the angles, do they seem similar?
Yes.
they do.
They seem similar. So now we're trying to find that center of dilation,
Okay.
right?
So. I still think they are. Why do we need the satellite?
All right, give me your attention real quick. 'Cause I know some people were struggling when we grabbed a pantograph and we didn't need that. Remember last week when we did the dilations, how you guys said it ended up like kind of looking trippy or whatever we said, like it looked like it was coming off the page or kind of going into the page. Remember why it looked real weird and how those things connected and where, like, how do we find that center of dilation? I don't want to give it away because you still got 3 minutes, but remember why it looked weird. You should be able to draw the center of dilation on your paper.
Now, should we be able to find out exactly where it is? I know how to find out exactly. Oh, I think I found it already.
You see that? The flipping of fractions is a move towards learning. On the bottom one, that one half guy took the other one by the foot and flipped him over, and now he's on his head. And he's like, oh, whale, and he's like, and he realizes that.
Chris, are we on topic with what we're doing in class?
No.
Okay, let's get there.
Oh, I knew it. I was like, it's right here. Or we could have just dilated from one of them. You just said so. You gave me one. No, how would you? Yes.
I see some really good work. Oh yeah. What's the scale factor?
Oh.
Lauren, what did I tell you?
Lauren thought she was done.
Alright.
I told ya.
7.1. Wait, we only need 2 sides. It's not. Here. So this one's 12.
You live in such a great
And
world.
this one's
You don't even have to
7.1.
hit enter. You just type it in the bar. Your answer just pops up.
Okay, so 12 does
71.
I feel like we screwed that. What? 12? 12 is 7.1.
7.1 is the scale factor.
Oh, never mind.
71.
No, 71.
Are we going to be done in a minute?
I thought they would be 8.
9.1.
We got a minute left on the time we had.
Scale
I
factor.
thought they would at least make it like 6 and 12.
Scale factor. Of
Nah, why would they make your life
7.1 over
easy?
12.
We can't do that.
Oh.
Alright, so from everyone's papers, I think most of us, actually I think all of us, remembered that that center of dilation is going to come from connecting all of your corresponding vertexes, or vertices, I guess if we're going to be accurate. So if we connect all of these, we should find one point of concurrency. Remember, a point of concurrency is where multiple lines come together. And out here, somewhere on the top right of your paper, you're going to find that center of dilation. So again, if we wanted to draw a smaller version of the triangle, we could do that. And then I heard some people struggling with lengths. All right, so we had the big length down here was how much did we get? 12. I think pretty much everyone agreed that that was just a solid 12. What about this length here?
7.1.
7.1.
So, Mr. Paul.
So to find that scale factor, How are we going to do this? And everyone was doing this as I walked around, but what do?
12 divided by 12.
We do the division, right? So our scale factor, if we're enlarging, is our larger shape divided by our smaller shape. If we're reducing, we just flip that over, right? And then we have a scale factor bigger than 1. Or, sorry, a scale factor less than 1, as opposed to bigger. So it's not very nice, right? It's a quote-unquote Mr. Hall move. Now, it's not, like, horrible, but it's not super nice.
Equal to like 1 degree.
Yeah, I like being able to trust what things look like. So there is definite strategy for why we do that. But yeah, that is kind of evil. So, anyone feel like reading? I doubt it. Alright, work along with me, please, or read along with me. Ario thinks to himself, there's gotta be an easier way. Right, like measuring all the sides and measuring all the angles. Like, this is really annoying to determining if two triangles are similar. So what if I only know that all of the angles are congruent? Like that's it. That's all you got. Would that mean the triangles are similar, and why? So we've already kind of talked about this, but really the point of this question is for you guys to familiarize yourself with the e-tool. So go ahead and open your Chromebooks. Go to the lesson for today, so 231. And then in problem 68, you should be able to click on the e-tool. That doesn't help it load any quicker.
If you close it and then you open it, hold for 5.
Have you tried turning it off and turning it back on? Has anyone ever watched the IT crowd? On that, it looks like the IT crowd, but it's actually IT.
What?
The joke in information technology services, like IT, is you just tell people to turn off their machine and turn it back on. That fixes most problems. All right, play with this. Get comfortable with how this works. This is an extension of Desmos, and remember, Desmos is what the state tests use now for all their interactive modules. So we want to be comfortable with Desmos. Play with this tool. Remember, the easiest way to get the CPM ebook is just Google CPM ebook and just log in with your Google. So you're still going to open a new tab. Just type CPM ebook because we don't need to go through the file. I know we can, but then the first thing that comes up with that.
How did you get to the Spanish one? It was in English.
What are you able to do in this e-tool?
Change the angles.
You can change the angles. You can rotate if you right-click or however Levi's right tapping his screen or something.
I don't know.
Can I move where the triangle is? Like, can I translate?
Yes.
How do I do that? Grab the center, right? Or grab an edge. But wait, if I grab an edge, that moves that edge. If you want to move the whole triangle, you got to grab the middle. If we right-click, some options pop up. Or if we just click in the middle. Play with all of these options. So grab the bottom left, this little expandy-looking guy. Check what that does. That gives you a dilation of your triangle. What is this top one? What's that a symbol for? Reflect it, right? So I can give it axis and make a reflection happen. And then the bottom right one, this is the easy one. We rotate. Take a moment, just play. We're going to do a lot with Desmos this year, actually. Why is it annoying?
Because we're clueless.
Because you don't know. What do you mean you don't know how to do anything?
Cannot do just like
Well, then this is going to get a little bit more frustrating. Don't worry, it's for your benefit.
Hey, they got it.
It's like the dentist, right? All right, so go back into the lesson. Go back into the lesson and click in part C. So the reason that we're going to keep going back in the lesson clicking on it is so it's been set up for us. So once you click 68 part C, don't do anything. Let's just get to here.
Oh.
And if you did something, then just go into it again. Like every time you reopen it, it will reset. Now, one of the things that we want to focus on this year is the fact that good mathematicians are efficient. Right? So while we could explain a million different ways to get 100, there are a few very efficient ways to get to 100. Right? So we want to, using the most efficient way possible, explain a sequence of rigid motions. Or sorry, not necessarily rigid, but a sequence of transformations that will get my one triangle onto my other. Now, do we want to make a choice of which one's the pre-image and which one's the image? Are we trying to go left to right or right to left? Right to left? Okay, so as a class, let's just go ahead and decide we're trying to go this triangle onto that triangle. So as you figure these out, write them down. Tell me what I would need to do, because I want you to be able to describe to me what to do to get that right triangle and land on my left triangle. So if you were already frustrated with just the open play, now you got to actually structure this a little bit. What sequence of motions will get me on? You're still on first. You want to do that? Go on first. If I drag one point, the point in the other triangle moves. Interesting. So what's our objective? So what things have you done? What all?
Dilated it, rotated it, and then now I need to dilate this like I gotta grab it and get this like one. But I can't do that.
Who can give me a suggestion for a first thing to do?
Reflection.
A reflection. Okay, then how do I reflect on here then? You were trying to explain to somebody how to use this tool.
You click in the middle of the large triangle.
Click the triangle.
You go to the top reflection thing.
Okay.
And you go to the left side, like the line with EF. Line
EF?
Yeah. Click it there, and you just align it with that line, so it just perfectly match.
Perfectly match?
Yeah.
Okay.
Click it.
Okay. All right, so I reflected. Across what axis?
Yeah.
Not an axis, right? I reflected across line EF. So if we were explaining this, we would have to say reflect line EF. And actually, if we were specifically describing, we would say reflect triangle DEF across line EF. What next?
You could do
Actually, hold on. Jacob, go ahead and give me a next step.
Translate point F onto point B.
Translate point F onto point B. Okay. So that would be like.
Or do D onto A.
Well, Jacob gave me the command.
Right, Jacob.
I'm following Jacob. All right, so I have reflected and I have translated. Now the translation, if we had a grid, we could explain it, but
Yeah.
I like Jacob's instructions. All right, so Richner, you want to weigh in?
Rotate it so that line DF and CB around point B so that
So wait, so I click rotate, but now what do I click?
click point B.
I click the point. Ooh,
and then
Nope.
line up those lines,
Okay.
and then
Line up the lines if I can. Okay. So I have done reflection, translation, rotation. Steven?
You dilate it. You click the center triangle thingy. Then you click the you can click on point E or B. The same.
I can click on E.
No, not E. B.
Ah,
Thingy up there.
I thought you said
Or you can
E.
do that.
So I got to click on point B, right?
Yeah, and then you dilate.
Why do I have to click on point B instead of point E? Steven?
Because they're like.
What am I
they're
choosing?
They both have that point.
Yeah, what am I choosing right now? After I clicked,
The center of a.
I'm choosing my center of dilation, right? So this being my center, that's where everything's going to expand out from. So I line it up. Kapow.
There we go.
I thought that was the movement.
Any questions on working the E tool? All right. I mean, I'm not surprised you guys are like better at technology than me. Go ahead and set your computers to the side for a moment or close them or something.
I'm not close enough.
Let's check out 69. Talk with your team about whether or not you think these triangles are similar. If they are, how can we map one onto the other? Talk with each other.
Yes. Yes. And now you have
Work
to
across
apply the F, and then you have to translate F on point
Actually, you
I.
don't need to reflect. You just need to translate point F to I, rotate,
Yeah, sure.
I was looking at it.
Yeah.
dilate, so that JH
Translate point F to I, rotate, so GF is and you dilate.
All right, we seem to have gotten somewhat quieter. All right, let's do thumb. Give me up, down, or somewhere in between. Are we similar? Yeah? How? Because the stuff I see up there, 87 is the same, but Thomas?
Let's do like 87 plus 25, 180. Subtracted from 180 equals 68.
What theorem are we utilizing?
Triangle angle sum.
Triangle angle sum theorem, right? Triangle angle sum says if I have three lines intersecting making a triangle, it sums to 180, and I can solve for that third. So, what theorem are we really using then? Like, after triangle sum, to say that the triangles are similar, what triangle similarity theorem?
It's like a
Angle, right? But that's kind of redundant.
angle.
So, open your Chromebooks again. When we look, hang on a second, then I'll release you. When we look at triangles, we know that we have angle similarity, right? This is a rule that we talked about last week. But if we go to 270's E tool, so, here's your directions. Create a triangle side lengths 4 and 5 and an angle of 20 between those two sides, included angle, right? As shown on the right, if a second triangle has an angle of 20 degrees and the two sides and the angles included, with lengths proportional, is the second triangle always similar? So prove it. Build it in your E tool using this. If it needs modified, if it needs turned, if you need to move anything to prove it, what do we
Way smaller, too bigger,
either? You just have to prove that they're similar. So as long as you could map it onto the other one through a series of transformations, we know it's similar.
Good job, Christopher.
Yeah. So are you less frustrated now than when we first started playing with the E tool?
Yes. So I didn't know that I didn't know that this meant dilation. I
Right now, the good.
Yeah, right.
It's so that's weird.
So this is not using angle, right? We only know one angle here. What theorem is this having us prove? Side angle side, right? Because the angle is included. The order that we would have to read this in is side angle side. So hopefully, through some rigid motions, we can map this onto the other.
Well, I mean dilation.
All of a sudden, you use the dilation. I'm sorry, I keep saying rigid. I don't know why I keep saying rigid. Sorry. Through a sequence of transformations. All right, now go to part B. So, example of side angle side. Right, 120 degree angle, the same on both. Can we, well, I'm trying to make a question that'll be hard for you guys to answer, but I think you're grasping this so well. Are these triangles similar? Ooh, wait, I heard a no and I heard a yes. Are these triangles similar? If so, what's the scale factor? So take a moment, because I heard a no and a yes. We have, so they're not congruent, right? Side angle side congruence would have to have equal lengths. How does 4 relate to 6, or how does 3 relate to 4.5?
Oh, they're not.
Try to get 4.5 to line up. 5.5.
No, it is.
Yes.
How's 1.5?
No,
you didn't.
That's
Yeah.
Talk with your team.
I got it.
We have some discrepancies here.
yeah, so do you say yes or no?
Yes, Chris. What is 4 times 1.5?
Because if you say yes, are you sure?
Don't goof.
Are you sure? Are you saying yes
You
or
don't
no?
goof.
Yeah, but 4.5 and 4.4 are not equal.
No. Yeah.
No,
we
need to match them
Even. Okay. I'm aware of that.
Gentle with the crumble.
So you're full.
So what do we think here? Yes or no?
Yes. I
I
can
think
say
yes.
so. 3/4 and 4.5 are 6. I can see. You see, I can see. Okay, try math one. Just try.
So,
Jack.
hands off keyboard for a moment. All right, up here. Sometimes technology is fantastic. Other times, eh. So let's just talk pure math for a moment. Forget about the tech. How does 4 relate to 6, or how does it get there? Thomas? Multiply by 1.5. What happens when I multiply 3 times 1.5? I get 4.5. Do we have the similarity, the same scale factor between the sides I have shown? Do we have congruent angles on the angles I have shown? Do we have similar triangles? Yes. So, I think what happened, Chris, here's the issue with Desmos's modules like this. Here's the issue, and I'm glad that you discovered this. Chris, you with me? This module has been programmed by somebody. It has been programmed that the angles round out to the 10th. Like, it gets rid of the 10th place, so it rounds to the whole digits. You're not seeing tenths of angles. However, the side lengths are showing you tenths. So you have to be careful when using the tech to first investigate with your math skills, right? You know certain math facts about similarity. We know that if the scale factor is the same and the angles are the same, that we have similar figures. We don't have to move anything here. We don't actually have to make it happen. We can just check the math. So be real careful when you're using tech. Whoever's programmed it, and you can dig into like how this module's been written. But yeah, just be careful.
View that source code.
Yeah, view that source code, right? We've talked about other similarities. We're going to go ahead and skip over that.
272.
So if you want to use the e-tools, you may. If you want to just discuss it with a team, you may. I don't really like how they structured this. We are comparing left to right. So we're comparing this. And I'm guessing you guys are probably going to want to use the e-tool. So if you want to pull up 72B, hear this. They might be.
Ooh.
That was terrible.
So 3, 5, 7, right? 6, 10, 14. Are they similar? So talk with your teams. Use the e-tool. Use whatever you want, whatever tech you want, or math you want. We only have about 5 minutes left, so we're probably going to need to try to be efficient with this.
They are still too.
Talk with each other. You guys got to come to a consensus.
Yeah, you gotta have this and
Yeah, we should be fast on this.
David is using his mapping line and it's staring at
Talked with pretty much everyone today. Trying to decide if I need to call anyone. Are they similar?
Yes.
What's scale factor?
2.
Yeah, it's easy. This one's just doubled. What about these? So with a reflection, we got to flip one of them.
Yep.
Scale factor? Still 2. Or 1/2. Remember, if we don't know what direction we're going, be careful. Clear this. Sorry, I don't know why that's not. I'm trying to condense what they wrote as a 2-day lesson into 1 day because I really think we can do it. We've already had this as a conversation, right? That if we know angle, angle, we really know angle, 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 which then we don't need the third angle because if we have the 2, it's excessive to name the third, right? So we already had that as a conversation last week. So play with this for a moment because we've talked about why side, side, angle, or angle, side, side, however you want to say. We've talked about why that doesn't really work. It's a bad word, right? But play with the e-tool. Can you write a proof? And this will probably be the last thing we do. We're going to have to split this and finish this lesson tomorrow. But could you explain why? Right? You can't just tell someone because it's a bad word and we don't use it and we've all decided that. Like, why? Why does side-side angle not work? Or have we been lied to and does it actually work? Or could it work in some situations? So dig into this for like 3 or 4 minutes and I'll get you guys out of here. But go ahead and play with this. To just write out the rest of the class. We'll pick up with this one tomorrow. Still try to get your homework. Choose any 6 out of that problem set. Yeah, just do whatever. So remember, proving that it could work does not prove that it does work. Because if you can disprove it, it falls apart. Remember, all because it works in one situation does not make it true.
one on top of the other and make it look like a snake.
You lost
So
me.
there's 6.
Excuse me?
If you put one on top of the other and make it look like a snake.
No,
Where's the snake?
put the middle of the bottom. Yes.
Why
And then
would
if you copy and paste like 96,000 more of them.
So make it
looks like a
tessellation?
snake. See, make it snake. It would look like snake. You can make it look like
Who thinks? All right, now this is a dangerous question. Who thinks angle side side can work?
It maybe could.
I mean, nobody lied
In
for
some
6
situations,
years in a row just to have this wow moment.
Well,
there are
we
other
didn't
ways.
say that it never works. We just said we can't claim. Like we can't use that as a claim, right? So be careful. Like what I'm asking is that it can, not that it always.
For this one, it probably could.
We have a right angle, it could work, but then at that point, you're just using the hypotenuse leg.
So yes and no.
Because like, are these triangles congruent?
No. Well, we don't know.
Angle measures are confusing. Silence, yes.
These two angles, or these two triangles, with how you see it, what's been shown, are they congruent? Do they? Okay, we'll ask an easier question. Do they look congruent?
They look more or less.
Okay, they look congruent.
Yeah.
So the question that we're going to dig into tomorrow is, do these triangles have to be congruent?
Alright, everybody, the answer is no.
So we have about
Skip.
2 minutes left. I want you to play with your E tool. If you think the claim is no, like right now, how these triangles are, they're congruent. Everything I see, they sure seem congruent. If you don't think they are, prove it.
What do you think they are?
Just take a couple minutes. Play with it on your own.
I linked one.
Remember, if you grab a vertex, you can move where that vertex is, like how the triangle is made. You can save your work in Desmos as well if you log in. So would you be able to make the claim that because they don't perfectly line up in each, that they're not congruent? Or would you need
It could be human error.
Okay. So would you
Oh, I
need
see
some
why.
support of
They
why it
are.
doesn't work?
No, Christopher.
Would you have to be able to like slice
You
your
link them
calculations?
together.
No, this is why.
You can go in here
You can do this. The
Mm.
angle is the same, but like you can.
So Lauren's realizing that if you blow open the side menus, you can see side lengths, you can see a bit more information.
and I want to make another triangle.
Yeah, I see why.
I
You
linked
think you'll be able to recreate that tomorrow?
Yeah, more triangles.
So, I say it works.
Alright, so for the sake of time, we need to get the Chromebooks put away, but we're going to pick up here tomorrow. If you think that you can prove these triangles are not congruent, I would invite you to share that with the class tomorrow. So don't just like, I know you guys talk about, like, you guys are in class together all day long, so I would ask that you don't divulge this information to each other. Save it for class tomorrow.
So I don't share the
Yeah, don't necessarily share. Like if you set up a really nice, like here's why it doesn't work. Like don't just give that to your classmates yet. Thank you guys very much. Have a fantastic day. Again, homework, pick any 6.
I already did the review preview for this, so is that?
That's what. Yeah, that's it.
Cool, yeah.